Hi everyone, and thanks for the invitation to speak at this EPA air quality event. My name is Liz Coleman from the Centre for Climate and Air Pollution Studies in NUIG, and on behalf of my research group, I'm presenting on the advanced measurements and modelling of impact of emissions on air quality in Dublin during the COVID-19 lockdown. So first, to speak about the global context, we're all aware of the impact of the COVID-19 pandemic, and due to lockdown, emissions fell across the globe. And Dublin was no exception to this. One of the most significant effects that we experienced in Dublin was the reduction of road traffic. This box whisker plot here shows the number of cars counted on the road in March, April and May in Dublin in 2019 compared to the same period in 2020. And the data is taken from the CSO. So in March 2019, the median daily number of cars counted in Dublin City was around 570,000. And there weren't many counts above or below this number. However, in March 2020, the median daily number of cars was lower at 333,000. But there were some days with much higher number of cars, right up to 550,000. This makes sense as lockdown only came into force in late March. However, in April, there was significantly less cars on the road in Dublin, with a median count of just 147,000 and not much variation around that. In a lot of our analysis, we'll focus on April as this month represents the strongest signal for the effect of lockdown in Dublin. Now, we know that air pollution is influenced by meteorology. So to that effect, we'll look at the meteorological records in Dublin of the lockdown period and compare it to the meteorological records for the 3 years previous. So first, if we look at rainfall, that's shown on this slide here. If you look at the medians of rainfall, the meteorology in 2020 looks similar to previous years. But on a closer look, if you look at the box sizes and the locations of the whiskers, we see that there were significantly less extreme precipitation events in March, April and May 2020 compared to the 3 years previously. This affects air quality because the influence that rain has on air pollutants in washing them out. And now if we look at wind speed, we see a similar story. Similar medians, but with less stronger wind events in March, April and May 2020 as compared to the previous years, meaning 2020 had more stagnant conditions overall, which would affect air quality. So now we move on to compare air quality measurements for the lockdown period in Dublin with the 3 years previous. The measurements were taken using regulatory instruments as well as advanced aerosol measurements from the Air Source network. So firstly, we look at NOx, which was measured at Wine Tavern Street, a curbside measurement site that would obviously be sensitive to traffic. As one would expect, there's a significant decrease in both median and range of NOx measured at Wine Tavern Street for lockdown 2020 in response to the lockdown. But now when we look at the nitrate concentrations, the nitrate aerosol concentrations measured by Air Source network, we see the surprising result that even though there's a reduction in NOx, there's an increase in nitrate aerosol, especially in April 2020 compared to the previous years. And we see a similar pattern with organic carbon, with many higher carbon events detected in April 2020 compared to previous years and a higher median. So what's going on? This table shows a summary of the medians and measurements taken in April for 2016 to 2019 compared to the medians for April 2020. So in April 2020, there was a 75% reduction of cars on the road and a responding 71% reduction of NOx at Wine Tavern Street. There was less of a reduction of NOx at Rat Mines because this site is residential and only partly influenced by traffic. However, for every other pollutant, including ozone, nitrate, sulfate, ammonium and organics, we saw an increase in 2020. Why did this happen? Well, then let's look at the Air Source advanced measurements to look at the species components of PM. So this slide shows ACSM advanced aerosol measurements that show speciated data taken from UCD in the period between January and May. Looking at the breakdown of the aerosol species components, coupled to analysis of back trajectories for this time period, allows us to identify 3 specific pollution regimes that occur in April 2020. Firstly, we have the clean marine airflow, which is our normal pattern owing to our prevailing westerly winds in Ireland. And this pollution regime is characterized by very low background levels and minor pollution peaks. These minor peaks will be from local emissions such as traffic or residential heating. You've got the second pollution regime, which is local emissions and some long-range transport. Here we've got some pollution coming from transboundary sources as well as local emission sources. And finally, you've got the long-range transport pollution event, where a lot of the pollution is transboundary. This is characterized by a slow rise and peak in the aerosol data and a high proportion of nitrate. Our aim is to analyse these three pollution regimes using the advanced speciated aerosol measurements, as well as state-of-the-art modelling to analyse the impact of the emission reduction due to lockdown in the context of specific 2020 meteorology. This we can do by using source apportionment techniques and adapting emission scenarios in models to replicate diurnal variations in solid fuel burning and traffic activity. We already have an air quality forecast app, StreamAir, which combines data from operational model simulations performed on a supercomputer with real-time data from all over Europe, allowing users to forecast air quality meteorology in their exact location for the coming days and to see real-time measurements taken all over Europe. StreamAir forecasts, although fairly well able to predict PM in Dublin, as you can see from the model versus measured plots in the upper right-hand corner, where the measurements are in the purple line and modelled are blue. However, StreamAir can't account for changes in emissions as a result of the lockdown. Because of its Europe-wide span, StreamAir has a horizontal resolution of 25 kilometres. And so a more tailored modelling setup was required for analysis of the lockdown effects. So we developed a new multi-scale nested version of WRF-Chem, comprising Ireland and UK domains, from a 9-kilometre resolution in the coarse domain to 3 kilometre over Ireland and 1 kilometre over Dublin. The high spatial resolution allows for more location-specific modelling. The model takes meteorological input data from ECMWF and chemical data from CAMS. The version of WRF-Chem that we applied uses advanced sophisticated chemistry scheme Mosaic, which includes secondary inorganic and organic aerosol and allows for size-resolved identification of aerosol components in simulated concentrations. We also developed the EU Air Plus emission dataset, which is an advanced dynamic 4D emission dataset using the most current emission data for the UK and Ireland. With dynamic, temporal and vertical features. Diurnal variation of NO and PM emissions are shown here in this animation. To simulate the lockdown conditions, we first ran a simulation without any traffic emissions. It is noted that the MapAir dataset also does not account for emissions of secondary solid fuel burning. And we know that fuel burning has been a major contributor to Dublin pollution events over the last years. But shown here are the modelled versus measured NOx and ozone in Dublin from March to mid-April. So from the beginning to the middle of the lockdown period. What's interesting is when traffic emissions are not considered in the model, simulated results underestimate NOx compared to measurements. However, the model overestimates ozone. After the lockdown period, there's a better agreement between modelled and measured NOx and ozone. This indicates the anti-correlation between NOx and ozone. So when there's a decrease in NOx, this can lead to an increase in ozone. Now looking at the modelled PM, measured versus modelled PM in Dublin from the period from the 1st to the 14th of April. This is when the emission reduction signal is at a maximum. There's a good agreement between PM10 in Ballyfermot and Phoenix Park between the models and the measurements. But looking at the PM 2.5 at Finglas, there are some local events that we are missing. These local events are most likely due to solid fuel burnings. And we can also see the long-range transport peak on the 10th of April, which is characterized again by that slow rise in peak. The model reproduces around 50% of this peak, and it's likely that there are some local emissions that are not considered in the model, hence the overall underestimation of the pollution event. Comparing the advanced speciated ACSM measurements to the model aerosol species over this time period, the model does a good job of replicating the pollution event between the 8th and the 12th of April. As said previously, there are some local emissions not considered in the model, but it is our intention to continue with the simulations and analysis to fully attribute the air pollution in Dublin over lockdown to emission sectors and elucidate the influence of meteorology, whether the meteorological events led to an increase or decrease in pollutants over the period. So in summary, we have generated a highly valuable data set combining measurements and modelling over lockdown. Simulations and analysis are ongoing, but initial results indicate that we can elucidate the impact of emissions and meteorology on air quality using the advanced measurements and models that we have built up. And the take-home message, multi-scale modelling informed by advanced measurements is the only way to elucidate the effect of lockdown or any sudden change in emissions. In 2020, the specific meteorological conditions meant that even though NOx reduced in Ireland, NOx-derived aerosols did not reduce owing to long-range transport events and specific meteorology that was conducive to formation of nitrate. April is the month that experienced the biggest drop in emissions as a result of lockdown. However, it was also the biggest meteorological outlier compared to previous years. To assess the impact of lockdown on air quality, or indeed the effect of any sudden drop in emissions, such as clean air policy or climate policy, we need to disentangle the effect of meteorology and emissions. Advanced multi-scale meteorological chemical models provide the tools to do this. We must build our national capacity for combining advanced measurements and modelling to assess future impact of emission reductions. So thank you very much. And if you have any questions, please submit them on the conference app. Thank you.